Hello everyone, welcome to my channel on data analytics. In this video, we are going to cover the popular knowledge discovery technique called frequent pattern mining in depth. This technique falls under unsupervised learning. The outline of this video is as follows. First, we introduce you the frequent pattern model, followed by the search space, a priori property, the a priori algorithm, and the demonstration. So first, let us talk about the model of a frequent pattern. The area is split into two parts. On the left side, we provide the definitions of a frequent pattern, and on the right side, we provide an example. If you consider any application, the, that application will have n number of items. For example, if we consider a supermarket selling the items pen, beer, cheese, books, bread, and milk, then the items I represent pen, beer, cheese, books, bread, and milk. Similarly, if we consider a healthcare system, then the items represent the diseases such as fever, headache, cough, and running nose. Finally, if we are talking about object detection in the imagery data, then the items represent various objects a object detection algorithm is going to identify. For brevity purposes, let us confine only to supermarket application. So given the items, a pattern or an item set represent a subset of items. For instance, if many customers are coming to the supermarket and buying the items, then a pattern represents the purchases of a customer. Say customer 1 purchasing pen, books, bread and milk. If another customer has bought the items pen, bread and milk, we will not say the items pen, bread and milk as a pattern because elements in a set have to be unique. So we remove the duplicates and we say a pattern that occurred as pen, bread and milk. A pattern has two important properties. First, the order of the items does not matter, and then second property is a pattern can contain any number of items. If you are familiar with 1 gram, 2 grams, you can think of a pattern as an n-gram, where n can be 1, 2, 3, and so on. So now we have defined the items, we have defined the pattern. Now what we will tell is we are going to define the transaction. Transaction is basically a transaction identifier followed by a pattern. For example, if a customer has purchased pen, books, bread, and milk, we simply say it as a transaction 1 containing the items pen, books, bread, and milk. Since row number by default indicates the transaction identifier, we can simply remove this information for reducing the computational requirements. A transactional database is basically a collection of transactions. So here we have shown you one transaction. If we add the purchases of multiple customers, then we get the transactional database. In this database, hidden patterns exist and we have to discover them. To find interesting patterns, we use the measure called support. Support is nothing but frequency of a pattern by total number of transactions. For example, if we consider a pattern as pen, books, and milk, then this pattern is occurring in 8 transactions, in 3 transactions out of 8. So we simply say the support of pattern P is 0.375 or 37.5%. So in the real world, it is often difficult for the users to understand the support values in percentages. So we can also use counts to represent the support. For example, we can simply say support of a pattern bread, books and milk is 3. It is also fine. We consider a pattern as frequent if its support is greater than or equivalent to the user specified threshold value called minimum support. For instance, if the user says that find all patterns that have support more than minimum support equivalent to 3, then we say pen, book and milk as a frequent pattern. The problem definition of frequent pattern mining is as follows. First, given a database containing many hidden patterns, we input it to a frequent pattern mining algorithm and provide the minimum support as an input. The mining algorithm will output all frequent patterns hidden in the database. They can be of any length. Now let us look at the search space. Assume a supermarket containing 4 items A, B, C and D. If we have these 4 items, then all combinations of these 4 items represent the search space. This search space is also called item set lattice. This lattice size is very huge because it contains 2 power n minus 1 item sets. Any pattern mining algorithm has to search this entire lattice and identify patterns. To reduce the search space, we use a priori property. It is as follows. Let us consider the items bread and beer in the database. In the database, bread appeared 6 times, while beer has appeared only once. Now I have hide the contents of the database and I am posing the following question. Guess the maximum number of times bread and beer have appeared together in the database. So please pause the video and try to guess how many times people may have purchased the items bread and beer together. If your answer is 1, then it is correct because beer has appeared only once in the database. Let us try to look at this answer in detail. In the entire database, bread has appeared only once. So, if I include any other item, let us say bread, then also at most bread and the beer can appear only once. Similarly, if I include many other items to beer, its support at maximum can only be 1. If minimum support specified by the user is 3, then we can clearly tell that beer has failed the test because beer cannot appear more than or equivalent to 3 times. Not only that, we can also say that all supersets of beer also fail the test. We don't need to scan the database to tell this fact. This property is called a priori property. That is, if a pattern fails the test, all its supersets also fail the test. Let us see how powerful is this property in reducing the subspace. So in the lattice, if an item set AB fails the test, we don't need to go down. We can simply say that all the supersets of AB simply fail. So this way we can reduce the huge subspace. So now let us look at the a priori algorithm. Given the item set lattice, we can perform search using two techniques. One is breadth first search technique and the another one is depth first search technique. The a priori algorithm uses breadth first search. It applies candidate generate and test approach to discover frequent patterns. So to understand this algorithm, let us go to the example. Assume we have the transactional dataset containing customer purchases. First, we scan the database and find all candidate items or one patterns. Next, we scan the candidate items and using the a priori property, we find frequent one length patterns. If we observe here, bread has failed to satisfy the minimum support equivalent to 3. So we pruned this item from the generation of frequent one length pattern. Next what we do is we perform the join on frequent one patterns and generate candidate 2 patterns. Once we have generated C2, we again scan the database and fill in the support values. Using then perform a scan on C2 using the a priori property, find frequent 2 length patterns. Next, perform a join on frequent 2 patterns and generate candidate 3 length pattern. Again, scan the entire dataset, determine the support, then find frequent 3 length pattern. you can keep repeating these steps until no more patterns can be generated. In our case, we stop at C3 because we cannot perform a join anymore on the F3 patterns. Now we look at the demonstration. For demonstration purposes, we are going to use the e-commerce data that is available in Kaggle. So if we print the transactional database, we can see that items in each transaction are separated by a tab space. If we look at the size of the transactional database, we can notice that it contains 24,446 transactions. Now, to discover patterns from this transactional database, what we are going to do first is we are going to install the PAMI library using pip command. Once we install the library, first we have to study the statistics of a database. For example, how many items are there, what is the distribution of transactions, and what is the sparsity of the dataset. So here we are going to study the statistics of the transactional database. So you can see that this transactional database contains a very large transaction with 1114 items. So very long transaction and very short transaction also exist. Then we can also plot the distribution of item frequencies and their transaction length to see the characteristics of our data. Once we have understood the characteristics of the data, what we can do is we can simply use the a priori algorithm available in the PAMI repository, okay, by providing transactional database and minimum support as the parameters and mine the process. Once we mine the process patterns, we can save them in the file and we can view them. Okay, I am not writing the code because as you can see, it takes lot of time for mining the frequent patterns. So once we discover the frequent patterns, we can look because it is the depth for search. The long patterns are generally at the bottom of the file. So we can find very long patterns like this. Okay. So we can say that a pattern in which customers have purchased Regency case stand, 3 tire, pink Regency teacup and saucer, so on, has the support of 303, that is 303 people have purchased this pattern. Such patterns are very useful for the domain expert because they can make decisions on arranging the items in a supermarket. Thank you very much for viewing our video. If you liked our work, please press the like button, share it with your friends, and subscribe to our channel for more information. The presentation material used in this video is provided in the below description. Please take a look. Please check the playlist for more information. Thank you.